Welcome to this introduction to writing SQL queries webinar. My name is Gethin Ellis. Now I've had a bit of a, we've had a lot going on here over the last few weeks, but to throw everything on top, I've had a bit of a chest infection as well. I lost my voice, and for someone who talks for a living, that's a little bit problematic. It's on its way back. It's still not 100%. So I'm jammed up here with sort of drinks and the hot tea and water and things. If I take a few more drinks than normal, then please just bear with me. As I mentioned, everything we do today is going to be recorded. I'll make a recording available to you afterwards. The demo script I'll make available, and I'll make my slides available as well. I'll send out an email with all the various links in towards probably towards the end of today, or maybe even tomorrow. But let's get started. Now, I like to write my presentations so they're in the form of a story. They're a bit more impactful. They're a bit more. It resonates a bit more with people. So this talk in particular is really for someone who's new to structured query language, right? It might be you're fresh out of university. It might be you're doing an apprenticeship. It might be that you're working in a job where you haven't needed to use SQL before. You might have used a lot of perhaps Excel or some other stuff, for doing sort of data analysis and working with your business's data. But you're now on this data-driven journey where you want to look at and access the data that's stored in a relational database so you can make better business-driven decisions, right? And more organizations, they are making their way slowly on that data-driven path. And because of this, it's becoming more and more necessary from people with different backgrounds to be able to access the data and to do different things with that data, query the data, get hold of that business critical data. Now, traditionally, SQL, structured query language, it might be a language used by, say, DBAs and developers. But these days, it's probably not just DBAs and developers that are going to use it. Right? You might be a business analyst, you might be a data analyst, you might be a hands-on CTO or hands-on head of IT. You might be someone that there's a lot of works with statistics and there's a lot of data analysis work using things like Excel. And now you want to get your hands dirty on your relational data, and that might be in a read-only reporting database. So with more and more people from different roles and backgrounds wanting to access data, I put together at the start of the year a series of blog posts to help people. And then I decided to turn this into a little bit of a talk and presentation so I can share that with people and make it available. People like to consume this data in different ways. So what we're going to really focus on in this session is the basics of a select statement. So you can retrieve that valuable data from your database to allow you to make better decisions based off that data. Now, if you're completely new to SQL, you're starting your first data job, you're moving from the realms of Excel and you want to write some SQL yourself, the most difficult bit really is understanding where to start. And there are some really useful free resources out there, like the W3 Schools has got, they've got quite a lot of code examples and code tutorials, and SQL is one of them, and it's really good for getting you started. There's lots of useful community-based resources like SQL Server Central. That's very specific to Microsoft's SQL Server and T-SQL, but there are lots of resources like that that'll talk you through the basics. And also, if you get stuck, you can ask questions on forums, you can ask questions on Twitter and LinkedIn. People will help. But ultimately, when it comes to writing SQL, it comes down to practice. All right, so coming to webinars like this, taking the stuff that's available to you, going away and practicing it. All right? And there are some useful paid resources as well. So, for example, I deliver a 2-day SQL Server training course, writing SQL queries training course. There are also really good books and stuff out there too, and there's lots of good authors. And when I finish today, I will send you a link to everything, including the free resources and some of the paid for resources too. Now, let me tell you a little bit about me. All right, so this will just sort of help you really understand why I'm here and in front of you. I've been working with SQL Server and the Microsoft Data Platform for about 20 years. And in that time, I've had a variety of different jobs, from report writer to web developer to DBA. And for the last probably approaching 15 years, I've been running my own consulting and training business, which is gethinanalyst.com. And over the last few years, we've partnered with our friends at Widen, and we offer a range of services in things like data platform architecture and design, migrations and upgrades, health checks. We offer training, and we offer quite a lot of, we offer some services in the analytics space as well. So that's why I'm here in front of you. What I'd encourage you all to do, if you have a pen at hand or just a bit of paper at hand, feel free to scribble down my email address. I'm going to tell you quite a lot of information today, so you might have questions on this afterwards. All right, feel free to send me an email. It is gethin@gethinellis.com. I'm happy to answer any questions that you may have. And also, if you are active on social media, please feel free to connect with me on LinkedIn. Look me up. I'm always happy to connect with people who come along and attend my my presentations and my webinars. So I'm always happy to connect. Now, my story here, right, it's about someone that's new. Now, if you've been on any of my webinars before, you may have come across somebody called Berry One. Now, Berry One's a figment of my imagination, right? She's someone I come up with. It's probably my alter ego, right? She's just a name that I made up so I can introduce her into stories. And, you know, when Berry was fresh out of uni, she needed to learn SQL. She may have had a little bit of SQL, but she needed to know more. And this is kind of my journey and how I went about learning and how I approached it. Oh, just another thing on there as well. I got awarded Microsoft Most Valuable Professional back in February as well. I keep forgetting to mention that on here. But anyway, any questions on the session today, please do reach out and ask. Now, we're going to look at SQL. If you've got a relational database, whether that's Oracle, MySQL, DB2, or whatever, it's going to use some flavor of structured query language. What I'm going to use in this session is SQL Server's version of that, which is called Transact-SQL. All right. Now, if you want to look and take part of some of these demos yourself, there are things that are available. You can do all this for free. So you can download SQL Server Developer Edition, right, or SQL Server Express. But I'd recommend Developer because it's a complete database solution. You can get Management Studio, and you can download the AdventureWorks Lite 2019 database that I'm going to be using as I go through today. These are all free to download. You just need a machine capable of running them. So if you've got a laptop with around about 8 gig of RAM in it, then it'll probably suffice for running the demos we're going to do here. If you are new to structured query language, guys, can you just leave yourselves on mute? Is that all right? Is that okay? We'll just get a little bit distracted. If you have questions, please feel free to pop them into the chat. That's no issue at all. Otherwise, I'll get a little bit distracted when your mic opens up. But any questions, pop them in the chat. I'll be monitoring chat, and I'll deal with all questions at the end. All right. So the demos we can look at today, that you'll be able to do these afterwards. You'll be able to do them yourselves using the data platform of your choice, and it's all available. You can do it for free. Now, before we get into writing SQL, we need to understand just a little bit about the fundamentals of databases and databases design, right? And as more and more organizations are making their way on this data-driven path, there's more and more people from different backgrounds looking to query the data, right? I said already, your DBAs and developers would have done this. When I started out, those have been the people querying the database. These days, it could be a lot of different people in there, and I put this all together, right? Now, writing SQL statements is easy. Writing them well can take some practice, right? And when you start out, it can be a little bit daunting, right? But once you understand the basics, you can build on that, right? So in this first sort of section here, we're just going to introduce some of the fundamental concepts around databases. Now, please, this isn't it's not intended to give you a complete overview of database design. It's just a starter for 10, introduce you to some of the terminology and give you that basic level of understanding, right? And every journey, I like that old saying, every journey of 1,000 miles starts with a single step. Well, this is your first step on that road, right? So you need to write SQL because the vast majority or a lot of your data is likely to be stored in a relational database, and structured query language is what you use to query a relational database, right? Every relational database, whether SQL Server, Oracle, DB2, are going to have their own flavor and dialect of structured query language. We're going to be using Transact-SQL or T-SQL, right? And there is an ANSI standard, there's an ISO standard out there. All these dialects, they adhere to that standard to some degree. Most will differ in some capacity as well. They'll all deviate from some degree. But what we're going to talk about here should be reasonably portable. So if you've got Oracle, if you've got MySQL, the queries we write, they should work on those platforms as well. Now we need to introduce some building blocks here, if you like. Right, we're going to introduce some of the fundamental building blocks. We introduce the concept of a table, and we're going to introduce the concept of rows and columns. Right, so we're going to get into these the sort of the basics here, and we'll keep it nice and simple. But our database ultimately is a model of real-world things. Right, let's call those real-world things entities. Right, now these entities, this model is going to represent the real-world things in your business. So that might be things like customers and orders and products. So the tables in your database represent each of those entities. Right? And sometimes you might hear someone refer to a table as an entity. Right? But the tables are where we store data about these entities. It's a logical storage unit for your data. Right? So your customer data might be in the customer table. Now that's important to know when you're writing your queries and want to retrieve data from them. Right? Now in that table, your database table will have columns and rows. Columns represent attributes of an entity. So a customer table, which represents our customer, they might have several attributes that make up our customer. Right? So our customer might have a name and a phone number and an email. Right? And these are represented as columns in that table. Now, rows in the table, they represent an instance of that entity. Right, so keeping with our customer table as an example here, each row represents a different customer. Right? Each row will represent one customer. And these entities can be related. Right? We'll talk more about that in a little while, but just looking at this example on this screenshot here, our customer might have an address. An address might be stored as a separate entity, but there will be a relationship between our customer and our address details. And again, that's quite important when it comes to when it comes to querying our data, right? When it comes to writing joins and querying data from multiple tables. Now, other things worth noting, right? Qualifiers are identified by their name, right? It's not their position, right? And rows are identified by values in one or more columns. Now, if you've got a unique column or a combination of columns that will guarantee to be unique, then you can create a primary key. Right? If your table has a primary key set on it, the database will enforce uniqueness for the columns that make up that primary key. So no other row will have the same value. Right? And that value can then be used to identify the row. So let's take go back to our customer table, right? We've got a single column called customer ID. That's the primary key on the customer table, and we can use that to find instances of a customer. The customer ID can be used to find that customer. So let's just say if we were looking on the screenshot here, you can see we've got customer ID 1, we've got Orlando G being our customer ID 1, and then we've got Keith Harris being customer ID 2. Right, so in this case, customer ID is the primary key in the customer table. And then if we go back to the previous example, the customer ID, let's go back a slide here. Right, you can see there we've got you can do this either way, and I'm not saying this is the right way, but we've got customer ID and address here that is used to build a relationship between these two. So it's a foreign key in this customer address table. Right, but we'll look more about that in just a second. All right, so how this looks. Here's my SQL Server environment. So we'll just switch to demo for a quick second here. Right, I'm going to scroll back up to the top. I have several databases on here. I'm going to be using the AdventureWorks LT 2019. Right, so AdventureWorks Lite 2019, and I've got Management Studio installed, and I've connected to my local server. And if I hit the use button there, it'll help me set the database that I want to get data from. And then I have a select from our customer table. I've talked a lot about the customer table, so you can see some of the data that's in there. Right, that's a simple select statement, which leads me nicely into this next section. All right, so simple select statements is what I've just run. It retrieves data. Now, the select statement, you specify the columns you want to retrieve and from which table you want to retrieve them. All right, so what you're actually really doing there is describing or defining how you want the results to look within that table structure. All right, so if I switch back here for just a second, right, I've got, it's a simple select star. Now select star as a simple select. This means select everything from our customer table. This represents a schema, so it's schema and then object name. Right, so the object here is customer, the schema is sales LT. Right, if I execute that by highlighting it, it returns every column and all rows. We get 847 rows and however many columns are in here for each customer. Now I'm just going to switch back to the slides for a second here, because what we have on this slide is a really useful slide showing the syntax and the order of the clauses in a select statement. Right, and we're going to look through some of these as we make our way through the day. Right, and we can refer back to this slide as we go along as well. Right, but you always need a select with at least one expression, one column expression. This doesn't actually mean a table column. It could be a constant, and we'll look at this with some examples as we're going along. But you can see there we have a select, and we have our column expressions, or the star, which represents everything. Right, then we have from, so we specify the table that we're going to retrieve these potential columns from. Then we have our join condition. So if we want to retrieve data from multiple tables, we can do so. The where clause allows us to filter rows that are returned. Group by is useful with aggregates and when we're performing calculations on the data. Having acts as a filter on those aggregations. And then lastly, in this list here, we've got order by, which allows us to sort the results as they are returned. All right. So we've got some of these in here. So these are really quite well, they're really quite useful. And you can see here from this example, we've got a select star from our customers table. This brings everything back. Now, the reality is this probably isn't best practice, selecting everything to bring it back. It can cause the database engine to do additional lookups. And generally, it's a good idea just to return the columns you want to include. All right. Now, don't get me wrong, I write select star all the time if I'm trying to explore the data and trying to understand the data. But when I'm writing queries for, say, a report, or if I'm writing a select for an application, I'm going to be very specific on the columns to include. Right, the select star makes the database engine do more lookups. It's going to return more data. It's going to return unnecessary data, right, that you might not need or use any further. Right, so all that extra work can be bad for performance. So it's better generally to list the columns you want to return and use in your query. All right. Now, when we've got our select list, we said we can have columns or column expressions. All right. So the column expression, which is going to be used in our select list, it could be a plain column, it could be a constant, it could be a subquery, it could be any combination of above. All right. Now, what you find, like in the examples you can see on the screen there, we're using a substring to extract the middle initial of our customer. So if I switch back here, right, so this is an example of column expressions. These are just plain columns. We've got first name and last name from sales, and it gives us our list back. Now in this second example, right, we are selecting first name, we are selecting middle name, but we're using the substring function. Don't worry too much about that for the time being. Just understand I am pulling out the first letter of middle name, and then I'm returning last name. So if I run this as one, you'll see something interesting in the results here. Right, we get first name and last name and the middle initial if they have one, right, if they have a middle name. But just notice the column doesn't have a name on here, so there's no column. The results now look a little bit incomplete, and this is where column aliases can come in quite useful. Right, so we can give this expression here, which is called in the substring, an initial. If you just use the plain column names, it'll take the column names from the table and include those in the results. If you do something to it, like use a function in this case to extract the middle initial, it doesn't. But we can use an alias to give it something meaningful. So if I run this now, right, you can see we've got first name, initial, last name. So it makes a little bit more sense. All right, and it makes the result set look better. And as you do more and more advanced things, having a result set with valid names in the column results is going to be quite important to you. Now you can also do this. If I scroll down a little bit here, you can rename it. So if I were to take, say, first name here and call it F name, if you wanted to be called F name in your result set. We can use the as and give this column an alias of fname instead. And then when I run that, it gives us the result fname. So it allows you to be a little bit more, you have a little bit more control on how that result set looks for you. Then we need to be aware of the accidental alias. So when we're listing out our columns, right, it's a comma separated list. So you can see here we've got first name, comma, then we've got our substring of middle name, comma, last name. Right, and you will note when I was using or giving these aliases here, I was using the as keyword. The as is an optional parameter. So if I take this and run this, you'll see it has ignored the fact there's no as and run it anyway, and it's renamed first name to fname. Now, because the as is an optional parameter, I always use as when I'm using column aliases, but just to avoid an accidental alias, it's better to put them in, because if I run this here, so I'm selecting first name and last name, so really if I had a comma between these, I'd get two results. But if I run this as is, it's still going to give me results back, but it's renamed everybody's first name to be under the heading last name. So you need to be aware of these accidental aliases. All right, so if you use as always when you're renaming a column or using that alias, it'll be absolutely clear what you intended, and someone coming along behind will find your code a little bit easier to understand. All right, it'll be very specific in what it is you were trying to achieve. Okay, so we've got our select, we've got our column expressions, we've got from a table. All right. Now we're going to look at the where clause. All right, so we've got our select list, we've got from. The where clause will allow us to filter rows. All right, so the where clause is what we use to filter rows returned by our query. In the where clause, we can write a condition. If that condition evaluates to true, then the row will be included in our result set. If it doesn't satisfy the condition, the row is not returned. So you'll find this where clause acts as a filter. Sometimes it's called a restriction. Now there's all sorts of conditions possible here, and it's very common, for example, to say perhaps test on a primary key. So if you're looking for a specific customer, coming back to our customer example, right, we can filter on primary key to get a specific customer. All right, so in this example here, we are looking for customer ID 19, and we are selecting from our sales table customer ID first name and last name, and we only want the row where customer ID equals 19. Because customer ID is a primary key, all right, if this exists in this table, it'll bring back just one row, so it's brought back John Beaver for us. I'm just going to scroll down a bit. So there's some other examples in here. So that's a simple one on primary key. In this case, we're perhaps looking for a range of customers. We're looking for customers whose customer ID sits between 19 and 23. So we've combined a couple of conditions here with an AND clause. So in this case, the customer ID needs to be greater than or equal to 19 and less than or equal to 23. All right, so we'll get more than one row back. You get 19, 20, 21, and 22 for those customers that are included in there. Now that's a where clause on the primary key. It doesn't need to be on the primary key. It can be on any column. So we're looking at modified date here. All right, so it's a similar thing. We've got customer ID, first name, last name, modified date from customer, where the modified date falls between the 1st and the 30th of September 2007. All right, so if I select that, click on execute, it gives us our results back, and I've included the modified date here just so you can see that it is in fact true and it adheres to these. And if I scroll down, there's 94 rows. They're all dated the 1st, right? So there's none in between. But I don't need to. I just did that to show you what it was doing. If I then use the double dash there to comment out that column, right, I can run this again, and now we'll just get three columns returned with modified date removed. And we can just assume that this is correct. Right, but I included the modified date there just to show you that that date does sit within that range. Now, when it comes back to building those operators, there are a number of things you can do. Right, so you can test for equality. I was doing less than, greater than, and equal to, and less than or equal to. You can combine them with an AND. You can combine You can combine them with an or. If you combine with an and, both conditions need to be true. If you're using an or operator, then either of those conditions can be true. There's a little bit on nulls I've mentioned here. We'll talk about nulls a little bit later on, but if you need to find unknown values in a column, there are some operands we can use to pull those up. But I'll come back to those a little bit later. Okay, there's no questions in the chat. I will come back to any questions at the end. If you do have any questions for me, feel free to pop them in there. But what we're going to just look at next is the like operator. All right. So the like operator can be used in a where condition, and it allows us to search on wildcards. Right, and it uses the % symbol as an operator and an underscore symbol as special characters. Right. So looking at this, we're looking at the example here. Right. It's better shown as an example, but I'll show you this in just a second. We've got our select statement, then we're saying last name. Now, instead of saying equals or is less than or equal to, we're saying is like a %. Right, which means it's going to start with an A and it can have any number of characters after it. Right, it can have none or many characters after it. If we were to put an underscore there, it would mean exactly, it can be any character, but exactly one occurrence of it. Right, so A% there is going to find all rows that start with an A. If that was then %B as instead of like B%, it'll find all the rows with the last character is B. And if it was say %C%, it'll return all rows where it contains a C. Right, if we were to change that to underscore G, right, so we'll have one character, then a G, it'll find everything where the second character is G. Right, now the little word of caution here, because how you structure this like condition can impact on the database engine's ability to use an index. So if you get this a little bit wrong and it can't use an index, you can end up doing a full table scan, right, which can be bad for performance. But we won't worry about that for the time being. But let me show you this as an example. Right, so we've got our select. We're going to say last name is like 8%. So if I run this, we get 46 rows back, and you can see that all the last names begin with the letter A. All right, but we can change this. So we could say, let's make it D. All right, so D needs to be the second character. It's not case sensitive, all right, but we can put this in here and execute. All right, so the last name is D. They're getting returned, and it's got any number after it. And if I were to change this, get rid of the underscore there, all right, this will return everyone whose first name begins with a D. All right, sorry, last name begins with a D, but we could make that sort of %D, which means all of the last letters of the last name need to end in a D, and it gives us those results. So you can see how we can do that wildcard search. Do that wildcard search in there. Again, all simple selects from a single table, column expressions. We're just filtering on the where clause, and we're using like to do these wildcard searches. Then we need to talk about the order by clause. All right. If you want the result set to come back in a given sort order, right, to guarantee the sort order, we must use an order by clause in our query. Even if the rows appear to be sorted, that might just be by coincidence. Right? So if you want to sort your results, you need to use an order by clause. All right? So you can add an order by clause to your query, and then you can specify how to sort. So you can add order by clause as we have got here. Right? So here we're ordering by modified date, right? And we're putting it descending. So it's putting the highest values first, and then we've got last name. The default is ascending, so then it'll put that in alphabetical order. All right, so we can put column names in there to specify we want to sort our results. All right, so we're sorting on modified date and then sorting on last name, and I'll show you an example in just a second. But you can use a column name, you can use a column expression, you can use a relative positioning here. I wouldn't recommend doing that. Right, but if I wanted to sort by, say, modified date, I could change this to say this is 1, 2, 3, 4. So I could say order by 4. Let's see if I can draw it in. Order by 4. right, and remove modified date, and then last name is number 3. So I could do 4 descending 3, and it'll give us our results back. Right. It's not ideal to do that. It will let you though. All right. So let's look at an example of order by. Right. So if I run this as is, right, and we've got a modified date between the 1st of June and the 30th of September in 2007. Right. If I run this as an example, you can see there we've got they're not in any particular order. They're probably in customer ID order, depending on how the optimizer has retrieved the data. Now, if I want this to be sorted on modified date, starting with the earliest, I simply add a order by clause to my query here. All right, so order by modified date, so it's the same select, just we're now doing an order by modified date. It'll do ascending first, so we'll put the earliest dates first. Right, and you can see we've got the 1st of June, and if we scroll all the way to the bottom, 197 rows later, you can see we've got the 1st of September. Right, if I wanted to change that order to put the latest dates first, I can change it to descending, just add descending to the end, and it reverts them back. So we've now got September being first in that sort order list. Right, the alternative to descending is ascending, which it will do by default. So if you leave out this switch, it'll make it in ascending order. Right, so that's the default behavior. And then just to prove what I was talking about just now, if I come in here and then type a 4 in here, right, and I'm going to run this, it's still done it by modified date. Now, okay. David's come up with a question. Can you use the UK date format? You can use the UK date format, David. It depends on the locale of your user and some other stuff in there. But SQL Server's got an internal way of storing the date format, and it's generally better to use this universal method here where you go year, month, day. Right, but you can present it how you want it to, and there are things you can do to change the date format as well. Probably outside of what we're going to talk about here, but there are some functions. The convert function, for example, you can specify a locale. Right, so I spoke about nulls earlier on. Right, nulls are interesting, and nulls can cause you no end of issue. Now, I'm not going to get into a big debate on whether you should be having nulls in your database or not. There's been a lot of academic papers written around nulls and having them in your database, but the reality is there are lots of databases out there where there are columns that allow null values. All right, so if I were to oh, right. Sorry, there's a few I missed out here, but I'll let you explore those in your own time. We're ordering by different dates. Now, this is my product table. If I run a select here, you'll see in size and weight there are some nulls being returned. Right? All a null is, it's an unknown or it's a missing value. It doesn't exist in the database. So if your column, so if I come into my AdventureWorks LT Lite and I go to tables, and then I look at the product table, and I look at the columns in here. There's lots of ways you can check this, by the way. Right, and then if I look at, say, weight, you can see that it says null, and you can see the standard cost is not null. So you have to enter a value for standard cost, but you don't have to enter a weight. Right, so when you're doing an insert, you don't need to specify a value. If you don't specify a value, it shows as a null in your result sets. All right. Now, when you come to write in SQL, all right, we're not going to go into the pros and cons of this. If your database allows null values, you need to know how to handle them, all right, because you can end up, or it'll help you avoid unexpected or errors in your results. And there are a couple of functions in SQL that you can use to help you deal with nulls. Right, now it's important I have to state here, right, null, it's an unknown missing value. It's not 0, it's not the same as blank, right, and it's not the same as the string null either. Right, but we need to know how nulls can affect the behavior of some of our queries, which is what we're going to look at in just a second, right? Just be aware of how it can work with things like calculations and doing multiplications and the impact it can have on your results, because then you can see how a null value can cause your results to also be null, which can impact on what it is you're trying to do. Right? Now, there are some functions we can use here as well, but I'm just going to switch over to my null example. So I've got this. You can see there's nulls in size and weight. Right? And now in this second query, I am taking standard cost, right, and I'm dividing by weight as cost to weight ratio. Right? So I'm going to take this query and I'm going to run it. Right? So if I divide standard cost here by weight, I get the cost to weight ratio. Right? Bit of a contrived example, but it does what I want it to, because when we get here where we are dividing by weight is unknown. Because it's an unknown value, the cost to weight ratio is also unknown. So we get a whole bunch of nulls in this column. All right, and that might be okay. Now I've got in one of the courses I teach, actually, we're working out people's commission and total pay at the end of the month. And commission is null for several employees, therefore they don't get any pay, because you take their base pay and add an unknown commission, you end up with an unknown result, right? But fortunately, in the standard, in SQL Server, there's something called an isNull function. We leave that there. We're going to look at class for the purposes of this, which is part of the standard, and you will find available in different products across the board as well. All right, so what we're going to do here, we're going to use this class function, right, and we're going to pass in weight. All right, now if weight has a known value, it will use it. If it has a null, it will replace it with 1. Right, so we're going to use that in our class weight, and then we're going to use that in our cost to weight ratio. So it's class weight. We know standard cost is it has to have a value for it to be entered into the database, so we can assume that that is good. Weight doesn't, so if it doesn't have a weight, we're going to assign it a weight of 1. Right, and now when I run this, my cost to weight ratio, they all get filled in, even with these null values in there, because we've replaced the null weights with a 1 here to give us our results. Now, whether that's useful, whether that's not useful is another matter. All right. Other things to consider here is if you want to put null in a where clause. Now I touched on this a little bit earlier on, right? But if I take this query here and we're doing our select and we're doing our collate, so we're taking we're using the class function to return weight if it's known, otherwise it's going to return 1. We're using the same in our calculation, and we're giving all these aliases. And then we're going to say where weight equals null. We get no results back. Now, the reason we get no results back is because nothing equals a null. A null is an unknown. So you can't say weight is equal unknown, because it's not true, and it needs to be true. All right, so there are some test operands we can use when working with nulls, and one is here is null. So if we wanted to calculate the ratio for all our products where the weight is unknown, we could do so. All right, so you see that all these here, weight is null. All right, and we can change that. If we wanted to calculate the cost to weight ratio for all our products where the weight is known, we can say weight is not null. And then where all there is a known weight, we get the cost to weight ratio being returned. Okay, so nulls are important. Nulls can impact on things like your aggregations. We don't talk about aggregations in this course. In an intro to SQL hour-long session, it's quite hard to get to aggregations, but nulls can impact on your calculations, particularly things like average. If you're trying to calculate the mean, it'll ignore any columns with a null value in there. All right, so if you're calculating the average, so using my commission example, I've got a table with 10 employees, 3 people with a commission. I think the 3 people's commission total up to, say, 600, right? So if you were taking that, you've got 10 employees and you want to take 600 divided by 10 to say the average commission is, say, 60. That's not what the calculation will work out, because the commissions are unknown. They get ignored. It'll take that 600 and divide by 3 and give an average commission of 200. Now that's not right or wrong, but how you calculate that average, or how you want to calculate that average, means you're going to have to deal with those null values. Okay, so just to finish up and take us through to a conclusion here, I'm going to talk a little bit about joins. Right now, the chances are, because of the nature of relational databases, right, you're going to want to get data from multiple tables, and to do that, you need to write joins. Right now, joins in SQL, especially if it's completely new to you, someone learning SQL for the first time, they can take a little while just to get your head around and understand. But once you've mastered it, you'll be using them all over the place when you're writing your queries. Right now, why do you want to get data from multiple tables? Well, we'll revisit the database fundamentals we mentioned earlier on. Right, we were talking about entities or tables and how they're related. So we've got a bit of an ER diagram going on here. So we can see there's a relationship between, say, our customer table and our sales order table. Right, so a customer is going to have orders. Right, and we might want to retrieve all the orders for a customer along with our customer details. Now, right, we looked at column aliases earlier on as well. You can use table aliases too, and I'll introduce some of those in the next few examples as well, because they can really help make your code easier to understand. So we're going to look at some basic inner joins here. Right now, I'm going to break this down. What I've done here is I have prefixed my columns. They're fully qualified, so they've got a schema, table, column ID. Right, there's a lot going on here. I appreciate that. Right, and this is all coming from the customer table. So we got customer ID, title, first name and last name, where a customer ID equals 29847. So if I fire that up and execute it, you can see there we get David Hodgkinson returned and his details. All right, and I think this one underneath. This is now retrieving from, so if we want to get the sales for David, we can take that customer ID and pass that into the sales order header table, and it brings us our data back. So this is the sales order header. This is what David owes us. Right. Now we might want that as one result set. So we have our select statement with the columns from each of the tables being returned. Right. Then we have from our customer table. Then we do an inner join on the sales order header. Right, our join needs a condition. So we're saying, right, we're going to get data from customers and sales order headers. How is that a relationship between this data? Well, in the customer table, there's a customer ID, and in the sales order header, there's a customer ID. So we can say where these match, bring us the results back. Right, and we can keep the same where clause where the customer ID is equal to 29847, and it does the join for us, bringing in data from customer and sales order header. All right, so you can see there we've now got data from our orders table and our customer table to work out what David owes us. So this is something that's instantly useful for us. We've talked about aliases, and I'm just going to introduce table aliases here. You can see here, this is a very busy query with all the qualified names in place, title, first name, last name, and so on, right, of the schema name, table name. What we can do is use table aliases. Right, now to do that, in the from clause, right, so this is sales customer, I can say as C. As again is optional. Again, I would recommend you use it. Right, and then inner join sales order header, and I've called this S for sales. I could have called it O for orders. You can call it whatever you like. It's whatever you give it. But everywhere else then where you need to reference, and you should always prefix your columns, so you're very explicit about where and which table these columns are coming from. So title, first name and last name is coming from customer. Order ID, sales order ID, customer ID, and total day is coming from sales order header. And then with the customer ID in the customers table matches the customer ID in the sales order header. All right, and we can include our where clause in here, and it gives us our results back. Once we've done a join there, we have matched on the customer ID in the customer table and the sales order table to bring back the order information for David Hodgson. Now, there are other types of joins. The inner join I've just shown you is by far the most comprehensive. It's probably the most the join you will use most frequently. But there are other types of joins. So there's left outer, right outer, and full. Now, just to show you this quickly, I'm going to quickly demo this here. All right. So previously we were where there was a match on the customer ID, we were returning results. In this case, when we use a left outer join, we are saying that if we write this as one line, it's probably the best thing to do. Everything to the left of this join condition, right, is the most important table. So we've got sales, we've got the customer table is the most important. We want everything from customer, and we want the sales order header details coming back, right, where there's a match. If there's no match, it'll return a null. And again, we're matching on customer ID, and we're saying where the sales order ID is null in this case. Now, I probably should have tested this before I run it. All right, so you can see there, this is returning all our customers that actually don't have an order in with us, or an order that's active. All right, so if we wanted to find customers who don't have orders, right, perhaps we want to target these as some sort of mail shop to get them in and buy in, then we can pull those out, and we can use a left outer join to do that. We want to return all our customers, right, where the sales order ID is null. Now, if I get rid of that where clause, right, this will now return all our customers, all 847 of them. Right, the vast majority don't have any orders. So if we filter where sales order ID is null, right, it'll take out any ones with an order. So that drops to 815, and all these will now be null. All right, switching that around, this I don't think it's possible to have an order without a customer, but we can see a right outer join is just the inverse of a left. So in this case, we are saying right now the sales order header table is the driving table. We want all rows from that. We could have switched this around where we could have said where this is coming from the sales order header, left join customer, it would have achieved the same thing and given us the same driving table. But you can't have an order without a customer, so that doesn't work in this case. So we've got left outer and we've got a right outer where we are specifying what the most important table is, and it'll return all rows from the one table and where there's a match in the others, otherwise there'll be a null. Full outer will return matches from each table. It's saying each table is most important. It'll bring the results back for us. If I run this here, well, there's 847 rows returned. We know there's no sales orders without a customer, but if there was an order without a customer, it would pull those out in here. And then if we just do a quick where s, it is not null there. Right, and it gives us the 32 customers here where they have an order. All right. So again, full outer join might not use a lot. Left definitely have a place. Left and right can be used interchangeably as long as you get the structure of your query in the right way. Right, but you have both options available to you, and you've got the full outer join as well. Right. Now, that brings me to the end of that session. I hope you've learned some stuff from it. I've covered an awful lot in the space of about 50 minutes. No doubt you will have some questions. We are putting on a training course in the middle of June. Right? It's the official Microsoft curriculum, querying data using Transact-SQL, DP080. It's running on the 16th of June. It's £750 plus VAT. I'm going to send you a discount code so you can get 50% off that. Right, SQL Hour, it's available there. I'll include the link in the stuff I'm going to send out. If you'd like to come on that and you're interested, just drop me an email. But I'll also include a link when we're sending things out. And you'll get 50% off for coming on this today. So if you want to come on that, please do. And you've got my email address. It's gethin@gethinanalyst.com if you've got any questions afterwards. Otherwise, feel free to type them in the chat now. And thank you all for coming. I hope you've got some use out of it. Thanks, Inga. There will be you'll get an email off me shortly asking for some feedback. It's like a 90-second survey. That email will come out at 1 o'clock. If you can just fill that in for me, that'll be most appreciated. But thank you all for coming. I hope you found it useful. It looks like you did. Thanks, Daniel. Thanks, Michelle. As I say, I've covered a lot. Any questions, you're more than welcome to drop me an email. Great stuff, Chris. Good luck with that, mate. Thanks, Sarah. Thanks, Goulston. You're welcome. Aladotun. Hope I said that all right, Aladotun. I may not have. Apologies. Thanks, Maria.